Hi, everybody. This mini lecture might not end up being so mini, but in this lecture, we are going to talk about animal behavior. So remember in the last lecture on this series, I was telling you guys about the modern synthesis. So the modern synthesis, as you recall, was the a long time after Darwin and Mendel. And Darwin and Mendel were publishing at about the same time. And I think I told you this, but just as a reminder, when Darwin died, they cleaned out his desk and actually found Mendel's manuscript in there, but there's no evidence that Chuck read it. And it wouldn't have been the kind of thing he would have felt confident in reading because it had a lot of math. It wasn't in English. I'm sure Charles Darwin took a look at that and went, maybe tomorrow. Okay, so 40, 50, 60 years had to pass before anybody decided to put Mendel and Darwin together in the same sentence. The next thing that happened on our road to understanding modern evolution has to do with something that's got a weird name, and it's called ethology, and that is the study of behavior. So before we discuss how that falls into evolution, let me tell you a true story. The first thing that I want to say about this is dog behavior. So if you look at the pity on the left, it's my left. I wonder if it's your left. I don't know. They are. Sorry, I'm distracted. Pit bulls, even if you love them, and I'm sure everybody who's listening to this knows a nice one. But if you're going to find an aggressive dog, a dog that is genetically predisposed to be aggressive, that is probably going to be a pit bull. And if you think I'm exaggerating or wrong or just hate pit bulls, you're wrong on all those counts. I have met many pit bulls that I love. But if you own one, your insurance goes up because if you're likely to be bit by a dog, it's a pit bull. And don't believe that dogs come predisposed to particular behaviors. I'm not talking about personality traits because that's a whole different conversation. But if you want to talk about dog breeds having particular innate behaviors, that is what we would call them. The first time I met a dog with an innate behavior was when I was in graduate school in New Mexico. And I had moved to New Mexico right after graduating with my bachelor's degree. So I got my bachelor's degree at Franklin Marshall, and I drive from Pennsylvania all the way across the United States to New Mexico. And I'm an adult. I have my own rental, and I'm going to get a dog. And so it's on my plan. I'm going to get a dog. So I'm driving with a friend from Albuquerque to Santa Fe, and we stop at an Indian reservation because they're pretty and interesting. And I was getting a PhD in anthropology. Better stop at the Indian res. And there's a little boy there with puppies in a box. And I'm like, oh, they're cute. And he said, you want one? I said, yeah, but I'm heading up to Santa Fe. I can't take it now. Maybe on the way back, if you're still here, I'll take the puppy. And he said, okay, well, you have to take the puppy now. And I said, I can't. He said, you have to. I said, no, I don't. He says, if you don't take the puppy, I'm going to drown it. So I said, okay, I'll take the puppy. He said, great, that'll be $75. So I got this dog. It was a great dog. It was well worth the $75 and a great story that came with the dog. And so a lot of the dogs, so if you don't know anything about New Mexico, and why would you, it is filled with, it's got the highest per capita number of adult illiteracy because of all the Indian reservations. And it's got the highest per capita number of PhDs because it's got Los Alamos National Labs and Sandia National Labs and the University of New Mexico. So it's a land of great of variation. And a lot of the Native American people of New Mexico have strong herding traditions. So they have sheep and cows and horses, and they have dogs that have helped them take care of all of their herd animals, take care of their animals. And that means that a lot of the mutts that you see on the Indian reservations are border collie and Australian Shepherd crosses. So this dog that I got was a border collie cross, and so even though I am not from New Mexico, I am a horse person, and I made friends with somebody who had cows. And twice a year, we would move the cows out of the city up to the mountains, and from the mountains, and they'd stay in the mountains all spring, summer, and fall. And then we'd bring them back to the city in the winter so that we could feed them and then eat them because cows are delicious. And but that meant that twice a year we had to get all the cows that were spread out everywhere and put them in one pile and convince them to get into a truck, which cows really aren't volunteering for this. And so I go out to the farm, and the guy who owns all the cows is there, but none of the other cowhands show up, and it's just me on my horse and him on his horse, and I got my dog. Normally we would have at least one other person, but preferably two because we got 20 cows to get into a truck. And but I got a border collie, and so even though I hadn't trained her to put cows in a pile, she wanted to put cows in a pile. She did all the work of a cowhand on a cow horse. And it's true, if you look at these trained dogs, they have a signal for left and for right and for fast and for slow. But with my dog, her name was Quark. She's a great dog. I had a, if you hold your hand out like this, I had, that meant stop because that was stay. And so I was able to tell her when to not chase a cow and to when to chase a cow. And she came predisposed knowing how to put cows in a pile. Now, right now, I don't have a standard, I don't have a border collie mixed with anything. I have standard poodles. And I can guarantee you, they would like to do a lot of things with cows, bark at them, run in circles around them, chase them, but put them in a pile. That's not a poodle's idea of what you do with a cow. So you've got these herding dogs that have these genetic instincts to put cows in piles. And in the 1950s, people are starting to realize that animal behavior has a genetic component. Not even human behavior, right? This is like animal behavior, that animal behavior has a genetic component. All that story, these stories I was just telling you about pit bulls and border collies and me on horse chasing cows in New Mexico. The whole point of that is to tell you that animal behavior, and start thinking about human behavior, has a genetic component. Okay, so in the 1950s, we add a field of science which did not exist in the 1940s or before, and that's called ethology, which means animal behavior. And we started studying behavior as an adaptation. So you remember those stories when I was telling you, okay, we've got all these rats and we are adding the pressure of a cat and food is limited. What are some of the behaviors that a rat might evolve to combat the pressure to get food in the face of limited food and a predator? And maybe some of you thought, oh, get a fast rat. Maybe you might have thought of getting a sneaky rat or a really smart rat. But some things could be some things that natural selection could work on for these rats to help them combat their environments might be based in behavior. Like, what if you had rats that wanted to cooperate? Then if you got like 2 or 3 rats working together, they could get the cheese and not get eaten by the cat better than if they were working solo. It doesn't look like rats actually work together in groups. They have social networks and they care about each other can't remember if I made you read that paper. I don't think so. I think it's too hard. But regardless, rats do have social behavior, but cooperation, like pack hunting that you see in dogs and even mongooses, that's not a thing for rats. But nonetheless, you could imagine it could happen. There's no reason it couldn't happen. It just hasn't happened. So step 8. So we're going through 10 steps that sort of get us a sophisticated understanding of evolution and natural selection, and a modern understanding of evolution and natural selection. We're at step 8, and that is this idea that natural selection can work on behavior. Okay, this is a funny cartoon. This is Gary Larson. So this is when imprinting studies go awry. And what the joke is, like in the 1950s, all this work that we're about to talk about, I think I said that like a Klingon, has to do with imprinting. And imprinting is if you have a duck or a goose and you hatch the egg in the house, about 14 hours after your chickie hatches out of the egg, it imprints onto something, which in the wild would be the mother, and it follows the mother everywhere it goes. Okay, so this joke is when imprinting studies go awry. So not only are the babies following the mama duck, but also the mad scientist is following the mama duck, which is Gary Larson's funny stuff. But what he's really making fun of in his kind and funny way is a guy named Konrad Lorenz, who was a European. And so the thing about this part of evolution, and actually all the parts we've talked about, is that the Europeans are doing the best work in this field. It starts with Darwin. We've got Mendel, Lamarck, Erasmus, Malthus, and people in the United States by the 1950s have heard about evolution and understand evolution, but the breakthroughs are all still coming from Europe. And Tinbergen and Lorenz are two paragons of, they really helped us understand how evolution applies to behavior. And they both studied birds, a lot of birds. And Lorenz spent a lot of time studying imprinting. So, which is kind of weird because one of the books that you're going to read in this class is called Monkeys in the Garden. And we're almost ready to start talking about that. And in Monkeys in the Garden, I interviewed an old professor from Harvard named Irvin DeVore. And Irv's hobby when he was a kid was animals, loved animals. And when he realized, so he himself experienced imprinting because he raised ducks, and realized that the ducks would imprint on him, that the ducks would imprint on chickens, that the ducklings were really foolish. And in fact, Lorenz got ducks to imprint on boots, which is pretty funny, although freeing for the scientists, because if you've got a bunch of ducks imprinted to you, they're going to sleep in your bedroom, which is only funny for a few minutes. So we've got Lorenz, and I'm talking about DeVore. So when DeVore was realizing that imprinting was a thing, nobody had ever studied it. Just think about that. Like, you guys grew up. I know we've got some older students listening to this, but most of you grew up knowing about imprinting, right? You guys, everybody has seen or heard the story about the kid who saves the cranes by teaching them the migratory patterns, by tricking them into thinking the ultralight is the mom. That's because imprinting. So Lorenz is studying imprinting. And we call Konrad Lorenz the founder of ethology and the founder of animal behavior. And he was the guy who showed us the adaptive value of animal behavior, which is just another way to say what I said on the previous slide, in that natural selection can act on animal behavior. Natural selection can act and generate adaptations that are driven by behavior rather than by physiology. So like Rat Attack, the movie with the rats in the bamboo, like in that particular case, natural selection worked on changing the how quickly the rats had babies, right? And how many babies they had, and could they cram so many generations in when there was a lot of food? So that's not really changing behavior, that's changing physiology. But natural selection can sometimes make you more cooperative, more paranoid, happier, more fearful. If you can, more likely to pair bond, more likely to like the people in your group. Those are all ways that natural selection works on behavior. And Lawrence was the first guy who started talking about this. Okay, so working at the same time as Lorenz is this guy named Nico Tinbergen. And he studied birds, but he studied wild, they're like seagulls, but they're called kittiwakes. And they live in Europe, and not too far from where Darwin was, as a matter of fact. And what Tinbergen gave us are the 4 whys. And so these guys are working at a time. Okay, so evolution has a dark underbelly. And it has been used for evil. It has been used for evil more times than anybody wants to count. Like anytime you want to say this group of people is good and that group of people is bad, people like to use evolution and Darwin to support that. So like the whole Nazi movement, the white supremacists, the mighty Aryan race, that all has its foundations. It doesn't have its foundations in evolution, but they certainly were. The Nazis were pretty happy to embrace, white supremacy and culling the unfavorables out of the environment, which is just really shitty. And it's just one person. I hate recording these. So not only did the Nazis use Darwin's idea as an excuse to call out African Americans, African Europeans, Africans, Jews, anybody whose skin wasn't white, because they're going for the purity of race. But some even after the end of World War II, even after the end of the Nazis, some of that policy came over to the United States. And so in the 1950s and 60s, in the South, people, mostly women, could be sterilized against their will and sometimes against their knowledge if they were unfavorable. Okay. And so who do you think is going to be sterilized against their will? Rich people? No. Rich white people? No. Poor people? Yes. Crazy white people? Yes. Black, brown people? Yes. And in fact, there are still women. There are women alive today who were either who went through forced sterilization, or were sterilized without their knowledge, without their consent, because they didn't fit into the social norms. Native Americans out west, whole swaths of them were sterilized against their will because of this Darwinian. People would use this Darwinian idea, trying to call the stupid people that's what they said. Anyway, so that's one reason why thoughtful scientists were like, let's pay attention to how we're using evolution and natural selection. The other thing that was happening that was making people like Lorenz and Tinbergen a little cautious and trying to set down some ground rules didn't have to do with bad politics and bad policy and the misuse of science, but had more to do with stupid science. So anytime they would encounter a behavior, instead of thoughtfully figuring out the evolutionary process that would generate such a behavior, stupid people would just say, oh, it's a function of evolution. Okay, evolution is more complicated than that. I know I've made it seem simple and accessible right here, but that doesn't mean that you should go home and say, oh, well, the reason she's wearing a lizard on her shoulder is because evolution selected for it. It's too complicated for that. So Tinbergen gave us 4 whys, and he said that all scientists should address these 4 whys before you try to explain animal behavior. And he didn't get there, but also human behavior. Okay, the funny thing is, so I rewrote these 4 whys to be more accessible and understandable, and I was teaching this class actually at Suffolk County Community College, and one of the students said, "Hey, Dr. Pochron, how come your 4 whys are 4 whats?" So that's true. Somehow I managed to change the 4 whys to 4 whats. Nonetheless, you'll bear with me. Okay. So what I'm going to do for the next 4 slides is describe each of the 4 whys. And but what I'm doing is I'm putting the questions in terms of imprinting, right? So if we're going to be studying imprinting as a behavior, because imprinting is a behavior, let's apply Tinbergen's 4 whys to the behavior of imprinting. Okay, so the first why. What is the immediate influence on the behavior? What makes the behavior change? Okay, so in this particular image, as Lorenz walks forward, the geese walk forward. The immediate influence on the behavior is the walking of the scientist. Now, it could be the walking of the mother or the walking of the hen. If these ducklings, these look like Canada geese, if these ducks imprinted to a chicken instead of to a goose, or to a pair of boots or whatever. What is the immediate influence on the behavior? Okay, so in this particular case, the answer is the immediate influence of the movement of the scientists. So scientists move, ducks move. Okay, question number 2, what are the developmental influences on the behavior? So when does the behavior start and when does the behavior stop? If we're talking about imprinting, it's actually pretty easy to study because imprinting begins at some number of hours after the birds come out of their egg. So with Canada geese, it's about 14 hours. So who's ever taking care of the nest 14 hours after the chicks get themselves out of the egg, that's when imprinting starts. But are the geese in this picture, did they stay imprinted to the scientists their whole long lives? If that wasn't the scientist, but the mother, would those goslings be imprinted to the mother until the day they died of old age? No, they would stay imprinted until they were almost adults or young adults, right? Until they don't need their mom anymore is how long. So developmental influences of the behavior. When does it start and when does it end developmentally? Okay. What is the function of the behavior? Oh, this is the one that people just love to say. Oh, this functions as to attract mates. This one functions to scare off predators. Maybe. Let's talk about it. Okay, so if we're talking about imprinting, what do you suppose the function of imprinting is? Why are these goslings following their mom? Well, if they were following their mom, probably they're doing it because the mom can show them what to eat, where to sleep, what is a predator, who's not a predator. Maybe the mom knows who's going to feed them breadcrumbs. Maybe the mom knows how to avoid the dogs. Anyway, just by running through her mom life, she's teaching these babies who are right behind her how to behave like a sensible duck or goose in this particular case. Okay, and the last one is, what is the evolutionary origin of the behavior? And what you want to do with this question is ask yourself, who else does imprinting? What are close relatives to geese? Quails, do quails imprint? They do. What about chickens? Chickens and ducks and geese? Chickens don't do it. What about ducks? Yeah, some ducks do it. Is there any other creature where the babies follow the mom right after, like in a nice orderly line? Do cats do it? Nope. Dogs? Nope. Horses? Well, they usually only have one, so that's not really a fair question, but you can see where we're going. There is one crazy mammal where the babies follow the mom in an exact little line and always in order. So whoever is number one is always number one. Whoever is number two is always number two up until the last one. And if one gets eaten, they just all move up the line. What animal is this? Warthogs. Baby warthogs follow their mom in a neater line than the geese in this picture. And they are always right there behind their mom in a very orderly fashion. So when we talk about the evolutionary origin of the behavior, so first you want to ask, if you're looking at a behavior and you're trying to figure out if it's got a genetic component, one way to convince yourself it's got a genetic component is to see if any other things that are close relatives to Canada geese do it. Okay, the answer to that is yes. But then the next interesting question is, does a creature not so closely related to the geese do it? In this case, warthogs. Why do warthogs do it? So for whatever reason that warthogs do it, Canada geese probably do it. And so you could get an idea of the selection pressure that led to that behavior. And by the way, this isn't on a quiz or an exam or anything, but if you have the same behavior, say imprinting, evolving for the same reason, moms teaching their babies in an organized way, but you have it evolving two completely different pathways, we call that convergent evolution. Evolution has converged on the same solution to a problem: how to raise babies in a predator-rich world. Because let's face it, everybody agrees that baby piglets and baby geese are all delicious. Not as good as cows. Okay. And so this is like, if you Google image Tinbergen's 4 Whys, you'll see something like this. It's ontogeny. That's a famous word, an annoying word for development, evolution, mechanism, and adaptive value. So if you're trying to come up with a cheat sheet, so if you're trying to come up with a sophisticated understanding about of why and how a behavior has evolved, Tinbergen has suggested that we tackle all 4 of these pathways. And understanding these 4 things can help us understand how biology plays a role in behavior. And again, we're talking about natural selection, which means you have to have variation, heritability, and selection pressure. And I said heritability, but Mendelian genetics, right? So cloning is not so useful here. Okay, and then just for fun, both of these guys shared the Nobel Prize in 1972 for their work in animal behavior. All right, good job. See you guys later.